Hey, algebra students. In this lesson, we're going to be learning how to apply the slope formula to find the slope between two given points of a line. Now, you may remember that before, to find the slope, we just inspected a graph and then we used the rise over the run to determine the slope. And that was a pretty easy way to do it. We could look at a spot where we knew what the height of the graph was, and then another spot we knew the height of the graph. We could determine the rise. We could look for a spot where we knew the horizontal position, and another spot we knew that position. We could determine the run, divide the rise by the run to get the slope. Well, there's a more mathematical way to do it. Here's the slope formula. To calculate the rise, we just need two y values, and to calculate the run, we just need two x values. The second y value minus the first gives us the rise of the graph. The second x value minus the first gives us the run. The interesting thing here is that if the rise goes down, the second y is going to be a smaller number than the first y, and we're going to be subtracting a bigger number, and our rise is going to be negative. This automatically gives us a negative slope if the slope goes down, a positive slope if the slope goes up. And this formula will always give us the slope. Now, what does it mean by y2, y1, x2, x1? Well, what this is referring to is two xy coordinate pairs. What we need, and if you look down here, these are the ones that illustrate this really well. We just need 2 points on a graph. If we can find 2 points on a graph and we know the coordinates, we can plug in the y value from the second point minus the y value from the first point. That's y2 minus y1 over the x value from the second point minus the x value from the first point. And then when we do that division, that gives us the slope of our graph. Now, here's one important thing to remember about this. It really doesn't matter which point you put first and which point you put second. No matter what, this is going to work out regardless. So even if you accidentally use the first point as the 2 and the second point as the 1, it's not going to matter because it will still calculate the correct slope for you. Okay. What you do need to do is be consistent. So whatever you call y, your first point, your 1 point, you need to make sure that you're subtracting that point's y value on the top and subtracting that point's x value on the bottom. What you don't want to do is subtract that point's y value on the top, but then plug in x1 here and subtract x2. Like if you accidentally put 1 point like across here, you're going to get the wrong answer. You need to make sure that you're taking your second point, like the same point minus the same point on the top and the bottom for your y value and then for your x value. All right, let's actually do some of these so you know what we're talking about here. In letter A, what we are doing is trying to, from 2 points, figure out the slope of the line that contains the points. Well, all we're going to do is do y2, the y of the second point is 0, minus y1, the y of the first point is -4. Now notice it's minus a -4. And then we're going to divide that by, and then on the bottom here, I have the x value of my second point, 3, minus the x value of my first point. In this case, it's minus -3. Okay, now I've got some calculating to do here to figure out what this is. So let's go ahead and do that. 0 minus a -4 is the same as 0 plus 4. On the top of my fraction, I have a 4. And then on the bottom, 3 minus a -3 is the same as 3 plus 3. So this is going to be 4 over 6. Oftentimes, I'm going to get slopes that are fractions. I need to simplify the fraction. This one's going to be a slope of 2 over 3. That means that this line is going to go up 2 over 3, up 2 over 3, as that's my rise over run. So moving on to letter B. Same thing in letter B. Y2 minus y1 is going to be 6 minus 8. I'm just noticing right away that's going to be negative on top. And then that's going to be divided by x2 minus x1. X2 is 5. X1 is negative 5. So this would be 5 minus negative 5. Do you see why it's been so important that you've gotten good at managing your negatives? Because that's going to be a huge part of what we have to do here is do a lot of minus and negative, and you just have to be comfortable with how to do that. All right, so let's do this. 6 minus 8 is negative 2. 5 minus a negative 5 is 5 plus 5. So on the bottom here, I'm going to have 10. Negative 2 over 10 is the same thing as negative 1 over 5, negative 1/5. So this is a graph that goes down 1 over 5, down 1 over 5. All right, let's take a look at C. Here, I'm going to have y2 minus y1, 12 minus 6, over, I have a 0. Let's see what happens when we have a 0. So this is going to be x2 minus x1. And you just treat the 0 like you would any other 0. 1 minus 0 is just 1. So this is actually quite an easy one. It's going to end up being 6 over 1. 12 minus 6 is 6. 1 minus 0 is 1. 6 over 1 is just 6. So for letter C, we have a slope of 6. That means it's going to go up 6 over 1, up 6 over 1. All right, it's on to letter D. For letter D, negative 9 minus 7 divided by, and in the denominator, we're going to have 2, that's x2, minus a negative 2. All right, so once again, I really have to be good at keeping track of these negatives. That's why we've been working on this so much this year. Negative 9 minus 7 is negative 16. And then let's see, 2 minus a negative 2, that's going to be 2 plus 2. Minus a negative is plus. So this is going to be negative 16 over 4. This simplifies to something really easy. It's just negative 4. So this graph is going to go down 4 over 1, down 4 over 1, and so on. All right, now we're on to a new type of problem. Determine the slope of the line that contains the points shown in the table. Sometimes your points don't look like standard coordinate pairs in parentheses. Sometimes they're going to be in a table, and sometimes they're going to be in a word problem, and we just have to figure it out. Okay, we'll get there eventually. Letters F through I are going to be easy because the points are just good old normal points. And you may recognize that H and I are like special graphs that we're going to have to deal with. But what about E? What do we do when we have a table? Well, we just treat this as if it's 3 XY coordinate pairs. And how many XY coordinate pairs do we need to determine slope? We don't even need 3. We just need 2 coordinate pairs. So I'm just going to select 2 of these. I'm going to select negative 2, negative 13, and 0, 1, because I think those are going to be the easiest ones to deal with. Anytime we're dealing with a 0, it's really easy to plug 0 into the slope formula. So I like that point. We could find the slope between negative 4, negative 27, and negative 2, negative 13. It would be the exact same slope. It'd just be a little bit harder to calculate. All right, so let's go ahead and do this. We're going to use negative 2, negative 13. I'm just going to write out my coordinate pairs. So negative 2, negative 13, and 0, 1. Those are my 2 coordinate pairs. All right, so y2 minus y1, it's going to be 1 minus negative 13 over x2, 0 minus negative 2. Y2 minus y1 over x2 minus x1. Let me just move this whole thing down so it's obviously its own problem here. Okay, so what am I going to do next with this one? Well, the next thing I'm going to do is 1 minus negative 13 is actually 1 plus 13, so that's going to be 14. And then on the bottom here, 0 minus negative 2 is the same as 0 plus 2, so it's going to be 2. 14 over 2 simplifies to 7. So this is just going to be a graph that goes up 7 over 1, up 7 over 1. I could, if I wanted to, and I really don't want to because it'd be so much work to do. Maybe it's not too bad. If you look at this, notice that negative 13 minus negative 27 is going to be negative 13 plus 27 is 14. And then negative 2 minus negative 4 is negative 2 plus 4 is going to be 2. This becomes 14 over 2 as well, or 7. I could have used these 2 points to calculate it, or I could have used this point and this third point, and it would have had the same slope. The slope is always the same between any 2 points on a line. Feel free to verify if you want, but that's going to be the case. All right, let's move on to letter F. Letter F has my coordinate pairs actually on the graph, but it's the same thing. Negative 2 minus 5 over, let's see, 4 minus a negative 7. So it's negative 2 minus 5 over 4 minus a negative 7. I'm guessing this one's just going to be sort of a confusing fraction. Negative 2 minus 5 is negative 7. 4 minus a negative 7 is 4 plus 7. So it's going to be negative 7 over 11. And that one cannot be simplified any further because both of those are prime numbers. All right, letter G. In letter G, we have y2 of 4, y1 of negative 5. So 4 minus negative 5 over x2 of 5 minus x1 of negative 6. So it's going to be 4 minus a negative 5 over 5 minus a negative 6. I see I'm going to have an 11 in my denominator again. That means that that's a prime number, so it's probably not going to simplify. So this is going to be 4 minus a negative is plus. 4 plus 5 is 9. And this is going to be 9 over, and then 5, again, it's going to be plus 6 is 11, 9 over 11. All right, letter H. Let's see. Oh, hey, I don't have to do any work on letter H. This is a horizontal line. I know the slope of a horizontal line because if I do y2 minus y1, it's going to be 4 minus 4 on the top of my fraction. 4 minus 4 is 0, so it doesn't even matter what the denominator is. My numerator is 0, so this is going to have a slope of 0. But we know that because it's horizontal. And then letter I, if I can find the numerator y2 minus y1, but the denominator is going to be negative 4 minus negative 4. Negative 4 plus 4 is 0. My denominator is 0. I can't have a slope with a denominator of 0. So this one is undefined or no slope. Okay.